All right, welcome and happy Friday. Just going back at it again with this computer build that I did. Just every day I've been spending about 45 minutes or an hour really just kind of revising and cleaning up what I already have here. So let me quickly go over what I have here. So I've got an intro that I think does okay for an intro. And then I've got this next paragraph for what I use it for. This is going to get deleted anyway. That's something I continually say because a lot of this is just kind of jot it down and clean it up and delete it all later. Not all of it, but this stuff that I don't like. And then here I've got steps to build computer, but this is kind of just I'm not going to go step by step describing like you gotta take these screws out and all that kind of nonsense. If this were like a video I were putting together, then yeah, I'd do that, but this is more just going to be like this is what I learned, or this is like, oh, I didn't know that. I mean, I didn't know how to shop for a CPU. Not that I still do, but I have a much better idea. So that's what this section is mostly going to be about. I also kind of just want to explain very high level, like what each of these deals is, like what you're looking for when you go to purchase this, or when anyone goes to purchase or build a computer. Because as I've mentioned before, just the target audience is going to be hopefully anyone. They'll just look at this, and hopefully be able to kind of get an idea like, oh, okay, this is something I can do. And then I cleaned this up where I put it into a table last time, and I separated out this stuff. So this is kind of like the necessities. It came out to $708, and if you want to add, I mean, you don't have to get 2 of these monitors, which I paid $150 each for. You don't have to get a third monitor. You don't have to get this keyboard. You might already have HDMI cables. This is just kind of in addition what I bought, because I didn't have any of this. I did have a keyboard, but as well as the Windows. I just had I didn't want to get a free version. I just felt more comfortable getting a license for Windows 10. And then this is all going to get deleted. And I'll just do a conclusion. So today I'm going to do this section. I believe I had this, and then I was just kind of free writing last time. So I want to continue the free writing and just see what I end up with. I think this section is going to be difficult. So I should just free write and then clean it up later. So let me read over what I have here. Heading into this, my main intentions were to build a PC that would be cost efficient, at the same time have specifications that would give me the ability to do some hardcore multitasking. I cringe every time I read that. My desire is to have the ability to understand the parts and pieces in order to upgrade, fix, or troubleshoot the computer if necessary. Meanwhile, I will need to have the parts and specifications that will give me the ability to host the specifications. Yeah, okay. Well, let's do that. Computer parts with the specifications that could give me that give me the ability to host Zoom meetings without lag, do some video editing, live streaming, and even dabble in PC gaming. I want to have it all. I should really kind of put a within a budget, of course. Initially, to begin, I needed to research exactly what I needed to buy. With my intended use described above, I started looking into what components I would need. I feel like this sentence is just a repeat of this sentence. Like I said, I was just kind of stream of thought writing last time. So with my intended use described above, I started looking into which components I would need. There are various of sources to help with research with the research process. I utilized 2 YouTube channels to help me understand tell me build my PC. Jay's 2 cents and Paul's hardware, which I have linked. I think if I do a preview here, it'll show me what so I'll have a picture up here of what the computer looks like, and then this will be taken out, but the title will be there, the date that it's published, and who is written by, which is me. And then this will be here. This I said I'll take out. You know what? This is coming together pretty neatly. And now all this will be deleted. So that's what that will look like. You can follow me on any of my pages. Oh, I wanted to see, yeah. So you can hover over this and click on it. That's what I wanted to do right now. And just demonstrate that it'll take you right to
the memory speed is a lot less important when it comes to the, why they go to 100% fan speed?
I think it crashed.
That'll take you right to their respective pages, which I think is pretty cool.
Excellent!
Hey everyone, and welcome to Paul's Hardware, my YouTube channel. I am Paul, and this video is an introduction to my channel. It's also a bit of a mission statement to set some clear standards for how I run things around here, to explain how I make enough money to do this full time, and more importantly, to make it clear what I think is okay or not okay when it comes to sponsorship and product placement in YouTube videos. My channel is about computers, computer hardware specifically, and how it performs and how different PC parts can be put together to build a computer for just about any use. Custom PCs are often built for PC gaming, of course, so I also like to test out graphics cards to see how they perform in games. I do a live show every Tuesday evening to talk about current technology news, and I also like to post time-lapse videos, reviews, of course, gameplay videos, build recommendations, and just about anything else that I think would be useful or entertaining for PC enthusiasts out there. I also try to minimize the hype and keep things relaxed in my videos because I don't know about you guys, but nothing gets me less excited about a new product than having some ad campaign screaming in my face about how awesome and groundbreaking it is. I highly value honest reviews, particularly when it comes to computer hardware that can cost hundreds of dollars, and if you happen to find my channel to be a solid resource for this type of information, then I'm doing my job right. I am constantly grateful to be able to do what I do, and I never want to lose sight of the humbling fact that it's viewers like you who make this possible. My channel will be nothing without your support, whether you provide it by simply viewing my videos, giving me constructive criticism and feedback in the comment section, or of course clicking the ever important like button. There have been quite a few stories in the news recently about YouTubers who don't seem to feel this way, who instead view their subscribers as a massive money-making pool of eyeballs and impressionable minds that they can exploit for profit. I think this is wrong and disrespectful to you, so here's my response. I will never accept money to review a product.
Oh, no.
It's sad that this needs to be stated since I always accepted it as an industry standard, but I guess I do. Not only is taking money for a review illegal, it is reprehensible. I've never created a completely sponsored video on my channel, and I have no current plans to do so. If I ever do, you can be damn sure it's going to be disclosed immediately and unambiguously right up front at the beginning of the video. To be perfectly clear, I make money to support my channel and my family in 4 different ways. One is YouTube ad revenue provided when you guys watch the pre-video YouTube ads at the beginning of the video. I always do short, skippable ads, and if you want to use an ad blocker, you are free to go ahead. After all, I've definitely used them myself. If you do enjoy my videos though, whitelisting my channel or signing up for YouTube Red are great alternatives. I also do sponsored ad spots in videos. These are at the beginning of the video. I try to keep them short in the 15 to 30 second range. They are always labeled as sponsor spots, and the ad and the product being advertised are always separate and unrelated to the video's actual content. Third is the Amazon affiliate program, which also provides me with some income. Basically, if I talk about a product, I can provide a link to Amazon down in the description to show you guys where to buy it. If you click that link, it tells Amazon that I sent you their way, and then I get a commission if you actually place an order. Fourth and finally, I have my store over at store.paulshardware.net, where you can support me by picking up some high-quality Paul's Hardware merchandise like shirts and hoodies, mugs, and pint glasses. And that is all, guys. I've often referred to myself as bad at business because honestly, there are many other ways that I could try to cash in on this YouTube thing. I could spam affiliate product links on Twitter all day. I could do weekly deals videos, which I'm not hating on, I just don't do them. I could line up more integrated ads for every video and post them at the beginning and the end of every video. I could, of course, accept money to make a specific video saying specific things that a manufacturer wants me to say about their product without telling you guys I accepted any money. But I don't know, either I'm just contrary or I'm jaded.
Anyway, I did watch a few of his videos. It's pretty neat that he's kind of taking a stance there and sticking true to what he wants to do. But anyway, I've got those linked. I wonder if I can make those a little bit more noticeable. Maybe I can underline them. Bold them. Let's see what that looks like. It's probably spending too much time on avoiding writing the rest of this. I think bolding them anyway. I think bolding them is enough, but I'll just underline them. Alright, so let me keep reading through this. With my intended use described above, I started looking into which components I would need. There are a wide variety of sources to help with the research process. I utilized 2 YouTube channels to help me understand the different components needed to build my PC. Jay's 2 Cents and Paul's Hardware are 2 extremely helpful YouTube channels that provide a guide provide guidance and answers levels, beginners. Okay. I had an idea of a few of the components I was looking to buy. I hate that sentence. So I ventured through Micro Center to browse and research a bit further. The easiest component of mine was the enclosure, being that I did not have any desire for anything extravagant and was going for budget with the case. I knew I wanted to buy a solid state drive for my boot up drive as well as to run applications from. Man, this section's gonna get wonky because I think I'm gonna lose people here. They're just gonna be like, cool. And they're gonna click away. Not that I have a whole lot of viewers or people reading this stuff, but I'm just writing it as if, you know, one day maybe they will. Alright, I knew I wanted to buy a solid state drive. I wonder if I should just kind of roll right, like if I should just bypass this here. What I'm trying to say is like, oh, I started with the solid state drive and the hard drive and the case, and then after that I had assistance. If I should just bypass that and just kind of go into like, here's a breakdown of like what you need, components breakdown, and how I ended up with the piece that I ended up with. And I can talk about like, I mean, honestly, the price that I got my CPU, Ryzen 7 2700X, like I paid $180 for it, which you can see right here. Yeah, so I think I should just do that. And this way I don't have to have like a, like I can just do this. Like this is the rest of my blog post here. And then obviously I'll go into the conclusion, which will be short, sweet, and simple. And then I can post pictures to this. All right, so let's move forward like that. Let me do this. So before doing that, I kind of want to clean this up then. Are two extremely helpful, provide guidance and answers for people. Anyone building a PC at all expertise levels. it became very helpful that they have an entire department dedicated to computer building. Oh, you know what? I'm gonna link my let's see if I can link that. Let's go here. Where's my... I don't want profile. I just want to go to my channel. Well, I just want to go to my channel. Well, all right. Look at this. It's like an endless loop. All right. Let's see. And I do this. Yeah. All right. I'll also bold that and underline that. Oh, I gotta put the other. Cool. All right, let me close that out. That's just a preview. All right, I should probably close. Shameless plug right in my own little blog post here. I'm just gonna make that part of the sentence because I've got too many brackets or too many brackets. All right, so that's better. So, yeah, I'm gonna do it this way. Became very helpful that they have an entire okay, I think that's how I'm gonna do it. This way people can read. Yeah, all right. That's how we're gonna do it. So this is probably gonna get deleted, shuffled down in here. And then why would you get a fancy enclosure? Appeal. Size. Let me just list that. All right. So I had an idea for a few components that I was looking to buy. Dang it. I went too far back. All right. Cool. Alright, easy. Nope, I'm still here. I had an idea for a few of the components I was looking to buy, so I ventured through Micro Center to browse and research a bit further. All right. I'm doing too much thinking, so I'm just gonna write things down, and rather than try to edit it in my head before getting it down, I'm just gonna write things down again, because if not, I'm just kind of writing a sentence and then erasing it, and then writing it and then erasing it. So it came very helpful. They had an entire department dedicated to computer building, although the employee who assisted me assisted me with and picked out all of the remaining pieces, so I was somewhat cheated of my research process for the CPU, GPU, motherboard. What else? I think that's it. I think it would have been fine with the RAM. Really, he picked out all those parts for me, and I was a little bit disappointed. If you are not interested in if you are not interested in doing much research, this may be the route you find easiest. rather than describing how exactly to build a PC step by step, I'm just going to list out the components, and let's get some music. Some focus music here. Let's see what I'm going through Play Music. That sounds kind of sad. I don't know if I want that. Romance by Guitar. That sounds kind of good. Alright, I like that. The easiest component to buy was the enclosure. Nope, I'm not there yet. I'm just going to list components, and I feel like I'm using the word components way too much. All right. I think instead of this, I'm going to do a heading. Yeah. Here we go. Now we're cooking with Crisco. All right, let's see. 1, 2, 3, 4, 5, 6, 7. That can't be right. 1, 2, 3, 5, 6, 7. 3, 4, 5, 6, 7, 8, 9. Oh, excuse me. I'm still waking up here. I think the music did it for me. Let's see Stars and Stripes for it. All right, I'm going with something a little more modern. Alright, so this whole thing I'll go back over. If you're not interested in doing much research, this may be the route you find easiest. Really, a computer build I'm gonna say 7. Case, CPU, RAM, storage, and power supply. 1, 2, 3, 4, 5, 6. Motherboard, of course. You can add on other components such as a DVD/CD drive, a Wi-Fi card. I'm gonna actually a Wi-Fi card. What do they call that, or what is that? Alright, so let's see. Video cards. Motherboards, processors, monitors, computer cases, RAM. Computer parts. Expansion cards, sound cards, SATA controllers. What is this? It's just memory. I don't know. Oh no, I didn't want to do that. I want to see computer parts. Parallel and serial drives and storage. Okay, I don't want that. Let me just do click on computer part. Oh no, they won't let me. All right. Memory, is this RAM? I suppose so. Cases and learn about streaming. Okay, so these expansion cards. PCI. Is that it? What if you wanted to have your... What if you wanted Wi-Fi capability? Where would you... accessories. I/O adapters. We're just gonna do PC build, Wi-Fi. Yeah, this is. Damn, that looks cool. Okay. Anyway, oh wow, that's not expensive at all. eBay, that's why. Newegg. Oh, okay. 66 bucks. I guess that's not too bad. Alright, I've gone off on a tangent. I'm stalling because I don't know how I'm gonna do the rest. It's kind of cool. My desk is not this big to do all of this. But I do have 3 monitors. I don't have cool speakers like that. Or a cool camera. I do have this cool microphone. Alright, let's get back on track. So no, that's not what I'm. All right, the case. Below this. I'm actually just gonna move. All right. Being that I did not have any desire for anything extravagant, my ultimate goal is to amount of money on this. I chose the least expensive case I could find. Should I do it like this? Cool master. Master box Q 300L. I'm looking in my. This is what I'm looking at. I just wanted to get the name of that right. I've got a few of my documents down here in the little drawer that I have next to me. All right. Ricin. Look that up. AMD Ryzen 7 27.
Cigarettes in the ashtray, reminiscing on those past days. I thought you didn't know where my last name, but
I'm not sure how exactly
traveled around the world. Think where you living at now. I heard you moved to Austin, got an apartment and settled down.
I'm gonna write these out because I'm by no means am I able to even like speak intelligently on any of these pieces, which is why I started the journal, so that I could like explain some of these things, but yeah. Why do I have it like this? Shell. All right. So that's. Sorry about that. Let's go with soothing classical harp. All right. Let's see. Yeah, all my writing just has to be kind of free writing. Otherwise, I will never write anything kind of like I'm doing right now, where I'm just kind of like, how am I going to do this? So, my opinion is the closure being that I did not have any desire for anything extravagant. My ultimate goal was not to spend an insane amount of money on this. I chose the least expensive case I could find. Ooh, I can add pictures to each of these sections. I have them somewhere. I'm I'll look them up real quick. Where would I have them? Yeah, not professionally, whoops. Not professionally done. But, I did kind of take photos as I was kind of moving along, but I don't know, maybe I can add that to the motherboard. That's terrible. I guess I can. What did I take a picture of here? Are those all my pictures? That can't be. Alright, well anyway. I'll see if I have more pictures and oh, okay. I filtered my search to computer. Tuesday, October 1st is when I built this. Okay. I have much more photos here. These are terrible. Well, this one. G-Skill Ripjaws. That's not the card that I'm using. I ended up returning that. I guess I did take pictures of... Alright. Well, that's what I've got, so let me just continue with this. I'll do the pictures at the end. This is the enclosure being that I do not have any desire for anything extravagant, and my ultimate goal was to try to not spend an insane amount of money on this. I think it's not, definitely not glass. Which is totally okay. I actually think a smaller case is preferred. Alright, I'm just messing around with that. This enclosure has a plexiglass viewing window and is large enough to fit the components that I need. Along with the aesthetics of I bought two blue cooling fans and will most likely purchase 2 more orange fans. In the near future. CPU. This, to me, is the most difficult component to buy. Looking to buy something with multitasking, minor video editing, and some for the price can't get much better. Let's see. Have 2 brands that products. Oh, you know what I also want to do that I just thought of? Up here. You can find We're gonna check out Joey Delgado's channel real quick. Joey Delgado.
Yo, what's up guys? Welcome to a $1,000 budget full PC build guide. If you've never built a PC before, you're good, I got you.
We're gonna be covering a lot in this video, but the most important part is that by the end of this video, you will know how to, from the very beginning, build the PC to the very end, which is actually playing games and streaming from the same PC. I'm gonna go ahead and tell you what's going down. First, I'm gonna be walking you guys through on how to build the PC. Second, I'm gonna show you guys how to install stuff. This includes Windows 10, the drivers for our parts, and the games. And then at the very end, we're actually gonna be playing Rainbow Six Siege while streaming it on the same PC. You guys are probably gonna be curious about the OBS settings. That of course will be thrown in as well, a little guide on that. We streamed for 3 days. For those of you guys who came through and hung out, I appreciate it. It was pretty chill. I had a lot of fun. We're definitely gonna be streaming moving forward. If you guys are interested in the exact quality of the stream, head over to twitch.tv/Joey'sLittleMind. It's linked in the video description. Anyways, guys, I'll shut up now. We're gonna jump into the PC building tutorial.
Our CPU of choice is the Ryzen 7 2700X. It's an 8-core processor and it comes included with a pretty beefy stock AMD heatsink. I disassembled it and spray painted only the top part white to match our theme. The motherboard we're using for this build is the Asus Prime, rocking the X470 chipset. These are the ports the board is rocking. We do have an optical audio port that'll come in clutch for anyone who needs it, a Type-C port, and plenty of USB ports. So when installing our CPU, we're gonna first pull out and then pull the lever all the way up. We're then lining up the golden arrow on the CPU with the arrow on our board. When lining it up, we're just gonna let it drop into place. It should just fall in. Do not push down on it because that may bend your pins and that's no good. That would be bad news. So with the stock cooler, we have 2 little clips. One of them has a lever and the other side doesn't. First, we're gonna be clipping on the side with the lever into here. So yeah, just put it in there. Then I'm gonna lift it so I could get it centered and then push it down and clip the other side. The way I clipped in this side was I pushed down with my thumb right here, and then with my other finger, I pushed it in. And to finish securing it, we lift our lever all the way up. It will kind of feel like you're gonna break something, but that's normal. You gotta use quite a bit of force and get this to clip in there. Now it's fully secure. So to power our fan, we're gonna hook it up into our CPU fan header on our motherboard. We hook it up here at the top of our board. The board also labels it for you. It's labeled CPU fan. So to control the lights on our LED ring, we need to hook up this cable right here. One end goes into the heatsink, and then the other end hooks up to the board. It's gonna be labeled RGB header 1. That's where we plug it in. We omit 16 gigs of RAM rated at 3000 megahertz. We chose blue because it matches that scarf. So pull up the lever on the 2nd and 4th row. So we start with the bottom end first, and then we line it up with the top, pushing down until this clips and our RAM's in. Our board does have plastic film. Get that out of the way. All right, so far it's looking pretty good. Now moving on to our storage. Our main drive is gonna be an M.2 500 gig SSD. This is where we're gonna be installing Windows 10 because when we turn on the PC, our system will then boot up quicker because of the speeds of our M.2 SSD. For the storage of our games, that's where we're gonna be using a 1 terabyte hard drive. Our M.2 SSD is gonna go under this right here. We're gonna be unscrewing this screw and this screw. These 2 pieces come included with our motherboard. So one piece is gonna go into the 3rd one. So our M.2 is now gonna sit on top of it. I'm gonna put it in at an angle, get it all the way in there, and then just push it down. There we go. Once we have it secure, before putting this back together, you wanna first remove the protective film on the bottom. Our budget was a bit higher this time around, so we splurged on our case. This is the 220T by Corsair. It comes included with 3 RGB fans already pre-installed, and on the back side of the case, it comes with a little controller for the RGBs. So this control hooks up to our motherboard by USB 2.0, which then allows us to change all the lighting effects of our fans. We did pick up an additional 3 fans to throw in there. First, we're gonna be putting in our I/O shield in the back of the case. Just snap it in. We have to make sure all the points on our motherboard line up with the motherboard standoffs inside our case. This case already has 9 motherboard standoffs in the appropriate position, so we don't have to modify anything. So I first line up the ports of our board with the I/O shield, push it in, and then lay down the board. We now secure it with these screws that came with the case. We're gonna be powering everything with a 600 watt gold rated power supply by EVGA. We're gonna slide in our power supply into here, make sure that the fan faces down, and then we secure it. So our power supply cables are black, but I want the cables in the front of the build to be white. So that's why we picked up some extension cables. We're only gonna be using 3 cables. Our 24 pin, our CPU power cable, which is the one that's split, and then an 8-pin GPU cable to power our RTX 2060. So here's our CPU power supply cable. Remember, it's the one that's split. That one's in. Next one's our 24-pin power cable. And the last cable for our graphics card, it's labeled VGA. CPU cable's gonna hook up in here. Be sure to connect these. Our CPU is ready to go. 24-pin cable, right here. The last cable is for our graphics card, but we're saving that for later. We're gonna be plugging in the ports of our case to the motherboard now, 1 cable at a time. This is our USB 3.0 cable. Goes in there. We're gonna plug in our JFP1 cables now. I'm gonna throw up a chart to help you guys out. Reset switch is gonna go right there. On top of it is the power button. And right next to the power buttons are power LEDs. Our audio cable goes in there. This USB cable is gonna connect the RGB controller. For our fans, right now I'm installing the 3 additional fans we picked up. These fans have LEDs as well, but they're not RGB, it's just white. So to connect all our fans, we're gonna be using 3-way fan splitters. I'm gonna plug in my 3 front fans to the splitter, and then to the splitter, I'm gonna be attaching an extension cable. So now this is gonna plug into our motherboard and connect all 3 of our fans. I'm gonna do the same thing for the other 3. I'll have these cables linked in the video description. So one of the splitters is hooked up here, and the other one I hooked up here. For our hard drive installation, we're gonna be putting it into the case, so just get one of these out. So to power our drive, we hook up a SATA power supply cable. And for our data, we hook up another SATA cable. They're both called SATA, and the other end hooks up to our board. And our RGB controller is also powered by SATA. I'm gonna be throwing an RGB LED strip in there. I'm gonna be placing it up here. The other end of our RGB strip, it goes in here next to one of our fan splitters. Our RTX 2060 is the final part we're gonna be throwing in our build. We spray painted it blue. Not the cleanest paint job in the world, but it will have to do. And this is my first time seeing a blue GPU. It's a pretty dark blue, and this is gloss spray paint. The card rocks 3 display ports and 1 HDMI port. We're gonna be clearing the 2nd and the 3rd slots. Our card's gonna be going into the first PCI slot. We're gonna put the lever all the way back. It already is back, just make sure yours is. And we're gonna line it up. Once it's in place, push it in, and that little lever will click back up. So our final part, guys, what's gonna really make our build pop is our figure. This is not a pop, but it is still Funko branded. This is a Day with Pikachu line. That's why we chose the colors we chose. Oops. Whoops. Sorry. And here he is. This is pretty small. It's like smaller than a pop. And I just remembered our graphics card is not even powered. So remember our final cable that plugs into right there. And now we are finished for reals this time. Everything's ready to go. Let's get some lights off. Okay, first boot up. Whoa, that's looking nice. Once we install the programs, then we'll be able to tame the lights to a single color if you wish. Okay. All right, guys, we're gonna be installing Windows 10 drivers and then playing games now, as well as streaming. If you haven't turned on bell notifications yet, be sure to do so you can be alerted when we post future builds.
All right, guys, so first we need a Windows 10 USB flash drive. I made a video tutorial linked in the video description on how to create this, or you can just buy a flash drive with Windows 10 already on it. We're just gonna boot the PC up now, and it's gonna take us where we need to be. All right, guys, installing Windows 10 is just a matter of clicking next for the most part. Oh my geez, the DPI on this mouse is very high right now. If you have a product key inserted here, I don't have one. I'm gonna select Windows 10 Pro next. Right here, pick custom. Then we're gonna be able to choose where we want Windows 10 to be installed. We're gonna select our SSD next. Let this do its thing, then the computer's gonna restart like 2 or 3 times. All right, once we arrive here, Windows 10 is now copied onto our SSD. You can unplug the flash drive now. Right here, this is easy, just a matter of clicking next, so I'll just skip to our desktop. We arrived at our desktop. First things first, motherboard drivers. This website's linked in the video description. First, we're gonna be downloading our audio driver, saving it to my desktop save. Our LAN driver, that is how I'm connected to the internet right now through an Ethernet cable. Saving the LAN driver to my desktop. LAN driver is gonna make sure that the Ethernet port is running well, it's stable, and it runs at its speeds that it's capable of. Utilities, we wanna get our RGB LED program, which is called Aura. Download. Desktop. chipset driver if you wish. I'm gonna skip it. Now if we go up here, I'm gonna be downloading the latest version of, there it is, the BIOS. I'm gonna be showing you guys how to update the BIOS. This is not required. It may or may not improve system stability once you update the BIOS. So yeah, download the BIOS, save as desktop. Going back on the website, and I just want to share with you guys that this motherboard is Ryzen 3000 series ready, so you can upgrade this up to a Ryzen 9 if you wish in the future. Pretty good stuff on AMD's part. All right guys, all drivers are zipped. We got to unzip them. Right click, extract all, extract. It automatically opens up the new folder, which is right here. This one we can now install, so we're going to do the same thing for all the rest. All right, cool. First, our audio driver, we're gonna find the setup. Yes. Restart my computer later. All right, next one, LAN driver. Gonna find setup. Yes. And as you can see, nothing even happened. That's what's supposed to happen. It's installed. Congratulations. Aura program setup. Yes. Next. All right, cool. Remember guys, the Aura program is what we're going to be using to change the lights of our LED strip and the ring light on our heatsink as well to any color you want, any lighting effect and whatnot. All right guys, we can get rid of everything now. Now we have our BIOS folder. So we're going to be putting in the updated BIOS file into an empty USB flash drive. Now we're going to be restarting our computer. When the computer is restarting, you want to keep pressing delete on your keyboard rapidly, and that's what's going to trigger the computer to actually boot up to the BIOS, where we then update the BIOS. There we go. Okay, we're gonna go over to advanced mode, and we're going to go over to tool, and then right here the flash utility via storage devices. Next. All right, so yeah, we don't have much plugged in, so it's automatically gonna pop up. That is the file. Click it. Yes. So yeah, then we're gonna update it. As you can see right now, we're at version up on top right here, 5204. We're updating to version 50.
Okay. So I just had that video playing while I was kind of typing out just some word vomit, but this does, I'm missing an E. That has to be capitalized. It's weird. Huh. I do not know. All right. Man, this is like turning into kind of a lot here, but I think because it's laid out this way, like someone who doesn't really care, I do want to get a little bit better with these descriptions here. Tasking.
Hello everyone. In this video we're going to talk about one of the most important parts of a computer, and we're going to be talking about primary memory or temporary storage, and this is called RAM. RAM stands for Random Access Memory. RAM is stored on the motherboard in modules that are called DIMMs. DIMM stands for Dual Inline Memory Module. A DIMM is a dual inline module because it has two independent rows of these pins, one on each side. A DIMM memory module has either 168, 184, 240, or 288 pins. And then the DIMM is installed on the motherboard in the memory slots. A motherboard can have a various number of memory slots. The average motherboard will have between 2 and 4 of them. In order for data or a program to run on a computer, it needs to be loaded into RAM first. So the data or program is first stored on the hard drive. Then from the hard drive, it's loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now, a lot of times, if the memory is too low, it might not be able to hold all the data that the CPU needs. And when this happens, then some of the data has to be kept on the slower hard drive to compensate for the low memory. So instead of the data going from RAM to the CPU, it has to do extra work by going back to the hard drive. And when this happens, it slows down the computer. So to solve this problem, all you need to do is increase the amount of RAM on a computer, and by increasing the memory, more data can be loaded into the faster RAM without the need of constantly accessing the slower hard drive. And the result is a faster performing computer. So this is why a computer with more RAM performs faster than a computer with less RAM. RAM requires constant electrical power to store data, and if the power is turned off, then the data is erased. RAM also comes in different types, such as dynamic RAM or DRAM. DRAM is memory that contains capacitors. A capacitor is like a small bucket that stores electricity, and it's in these capacitors that holds the bit of information, such as a 1 or a 0, because that's how computers read data, which is ones or zeros. And because DRAM has capacitors, they have to be refreshed with electricity constantly, because capacitors do not hold a charge for very long. They constantly leak. And this refreshing is where we get the name dynamic. The capacitors have to be dynamically refreshed often, otherwise they will forget the information that they're holding. Another type of memory is called SDRAM, which stands for synchronous DRAM. And this type of memory is what is used today in RAM DIMMs. SDRAM also has capacitors like DRAM, but the difference between SDRAM and DRAM is basically speed. The older DRAM technology operates asynchronously with the system clock, which basically means that it runs slower than the system clock because its signals are not coordinated with it. But SDRAM runs in sync with the system clock, which is why it is faster than DRAM. All the signals are tied to the system clock for a better controlled timing. So as stated before, RAM is stored on the motherboard in modules that are called DIMMs, and these DIMMs come in different memory sizes. Today they range anywhere from 128 megabytes to 32 gigabytes per DIMM. SDRAM is also rated at different speeds, but before we talk about the speed of RAM, we need to define some things first. Now the term 64 or 32-bit data path refers to the number of bits of data that are transferred at a time or in one clock cycle. The more bits that are transferred in one clock cycle, then the faster the computer will be. Now DIMMs have a 64-bit data path, which means that they can transfer 64 bits of data at a time. Now prior to DIMMs, there was an older RAM module called...
Alright. I think I've had enough of that video. I should link videos
Hi, my name is Alex Hudak. I'm an offering manager at IBM, and today I'm going to talk to you about what is a GPU. So I get some pretty basic questions on GPUs, and that's what I'm going to go over today. First question is, what is a GPU? What is the difference between a GPU and a CPU? So I'm going to represent those here. And then lastly, why use a GPU? And is it even important to use a GPU on cloud? So let's start first with what are computations. Computation at a time.
Here. Oh, this guy has a good tech quickie. He's got a good channel.
We talk a lot about graphics cards on this channel because most of the time it is the most exciting part of a gaming PC and the biggest contributor to your rig's gaming performance. But that means we're talking a lot about technical terms like core clock, GDDR5, CUDA cores, ROPs, and so on. If you know what all those terms mean, good for you. Gold star. But for those of you who don't know, for the layman out there, this video should help you understand the basics of what they mean and whether you should be actually paying attention to those when shopping for a new GPU, or graphics card. The GPU is the actual chip, but sometimes we say that. See, this is why we're here. Let's actually start there. The terms graphics card, video card, and GPU are all used to refer to one of these. But the term GPU, or graphics processing unit, actually only literally means the physical chip on the card's PCB. Now see, I told you this was the basics. The reason this distinction is important is that different graphics cards can be based off the same GPU. For example, the two largest desktop GPU makers, AMD and Nvidia, will release a reference version of a new graphics card like the Radeon RX 480 or GeForce GTX 1080. Then vendors like MSI, Asus, Gigabyte, and so on often sell that reference design, but they also design custom versions with unique coolers, I/O ports, and sometimes a higher clock speed. But all those unique versions actually have the same chip at their core. So they're not really that unique, are they? Now it's also possible to have two GPUs on one graphics card, like AMD's R9 295X2, Radeon Pro Duo, or Nvidia's Titan Z. Those can get you tremendous amounts of graphics horsepower, but since you're technically running two GPUs, the card's performance in games will depend on how well those games support multi-GPU performance. Nvidia's name for their multi-GPU connection is SLI, and AMD's is Crossfire. Sometimes, like in the case of Nvidia's 70 and 80 cards, like the GTX 970, 980, 1070, and 1080, two graphics cards at different tiers will have the same chip, albeit with some modifications. The GTX 970 and 980 are both based off the Maxwell GM204 GPU, while the 1070 and 1080 are based off the Pascal GP104. Now speaking of Maxwell and Pascal, you might be aware that those terms refer to the GPU architecture, but what is that? A GPU's architecture is the platform or technology it's built on. New graphics architectures are developed by AMD and Nvidia around every 1 to 2 years, and they often shrink the size of the physical components of the processor, which allows them to fit more features and transistors onto the GPU die. Die meaning the actual silicon in the chip. Architecture changes can also reduce the amount of power required to run cards.
The sine qua non of any gaming PC these days is the graphics card. I mean, there's plenty of other cool components that you can throw in your rig, but nothing quite matches the experience of unboxing and slotting in a new GPU to turn a run-of-the-mill computer into a gaming battle station. But hold on a minute. Have you ever wondered why we need a separate GPU at all? I mean, instead of the whole PCI Express card paradigm, why haven't we seen something like a dual CPU board where you can tell your computer to use one CPU for CPU things and then the other CPU can be just for graphics? I mean, are those big clunky cards really necessary? Great question. On the surface, CPUs and GPUs appear to be very similar. They are both silicon-based microprocessors mounted to a PCB with heat sinks attached to them. But when you look at their microarchitecture, they have some fundamental differences that make them suited for different roles inside your PC. Think of it like this. Many people go around carrying Swiss Army knives everywhere they go because they're very useful multi-purpose tools. They can cut things, they can open wine bottles, and even pick last night's broccoli out of your teeth. But suppose you're unlucky enough to need an operation because you met with an unfortunate LAN party accident. You probably don't want the surgeon just flicking open a Swiss Army knife and going to town. Instead, he or she will use a surgical knife or even a laser cutter. They can't do all the things a Swiss Army knife can, but they're specialized devices that can do one thing very, very well. Similarly, your computer's main CPU is good at doing lots of different things quickly. Modern PCs are very general purpose machines that can do, spreadsheets or write horrible fan fiction or illustrate aforementioned horrible fan fiction, make Skype calls, listening to deeply embarrassing music, play games, edit audio, video. The list goes on. Make Skype calls or illustrate sheets or quickly. Modern PCs are very general purpose machines that can do, spreadsheets or write horrible fan fiction or illustrate aforementioned horrible fan fiction, make Skype calls, listening to deeply embarrassing music, play games, edit audio, video. The list goes on. Because of this, your CPU needs to be able to handle lots of random and diverse instructions efficiently so that you can multitask without wanting to pull your hair out. GPUs, however, are really only there for one purpose, with an asterisk, to render graphics, which involves doing millions of very similar calculations at the same time in parallel. Because of this, GPUs are focused more on raw throughput than a CPU, which is designed to be much more versatile and balance all these different workloads like a waiter with, 18 plates stacked up on top of each other. GPU architecture usually features lots and lots of identical compute units that deal with solving the similar mathematical functions that determine how a bullet's trajectory or waving blades of grass or whatever show up on your screen. In fact, the highly parallelized nature of a GPU has led to a growth in popularity of general-purpose computing on graphics cards as well, commonly known as GPGPU. Certain applications, aside from games, this is where the asterisk comes in, can take advantage of higher-end GPUs. Things like Bitcoin mining or Stanford University's Folding at Home project, which calculates the way that proteins fold for disease research. Both of these require the type of heavy number crunching that GPUs excel at. But while GPUs are finding uses other than just gaming, you probably won't want to try and run your operating system on a graphics card, as the differences between your GPU and CPU are still very significant. So don't expect the idea of using a separate graphics card to go away anytime soon. And after all, there's nothing quite like showing off your high-end card through the side panel window to be the envy of all your friends without having to hide it under a CPU heatsink. Speaking of hiding, I'm sure if you run a small business, you're...
I think I'll link this video. Dang it. All right, I think I'm gonna call it there. Let's just preview that, just see what this is starting to look like. Maybe I might keep these headers in here. Obviously get rid of that. This is starting to come together. I kind of like what this is doing. Oh, I wanted to see if that worked.
The sine qua non of any game.
It does. All right. It's getting close. I think I'm getting closer to what I want this blog post to be. I need to read it over and over. Because none of it sounds good right now. Not none of it, but pretty much from like here on, it's just kind of jumble, but it's okay. I only need to jumble 1, 2, 3 more times, and then the conclusion can be like that long, and then I can get rid of all this. But I think it looks cool. Maybe I won't add too many pictures, because my pictures aren't great anyway. All right, I'm gonna close it off there. Have a great rest of your day. Happy Friday, and I'll probably be back on Monday, if not Tuesday. Take care.